Namaste everyone. Welcome back to the channel. I am your Java programming teacher, and today we are diving deep into a very important and often misunderstood feature in modern Java, the optional class. This class, introduced in Java 8, is a game changer for writing robust and cleaner code, helping us gracefully handle situations where a value might be absent. Many developers find optional a bit tricky at first, but by the end of this tutorial, you will have a solid understanding of its purpose, how to use it effectively, and how to avoid common pitfalls. We will explore its core concepts, look at practical examples, and learn some best practices. So, grab your virtual notebooks and let us begin this exciting journey to master the Java optional class. Alright, my dear students, before we jump into optional, let us first understand the problem it aims to solve. For decades, one of the most notorious issues in programming has been the dreaded null pointer exception. It is often referred to as the billion-dollar mistake because of the immense cost it has inflicted on software development in terms of debugging time and application crashes. A null pointer exception occurs when you try to use a reference variable that points to nothing, that is, it holds a null value, and you try to invoke a method on it or access its fields. This often leads to unexpected program termination and can be very difficult to track down in large applications. Imagine a scenario where a method is supposed to return an object, but sometimes, for some reason, it returns null. If the calling code does not explicitly check for null, boom, you get a null pointer exception. This forces us to write a lot of repetitive null checks, making our code verbose and less readable. This is exactly where optional comes to our rescue. Now that we understand the problem, let us introduce our hero, the optional class. Think of optional as a container, a box, that may or may not hold a null value. It is like a gift box. Sometimes it has a gift inside, and sometimes it is empty. By using optional, we explicitly state that a value might be absent, forcing the caller to handle both scenarios, when the value is present and when it is not. This makes your code more expressive and prevents those pesky null pointer exceptions at compile time rather than runtime. There are three main ways to create an optional instance: optional.of for a non-null value, optional.of nullable for a value that might be null, and optional.empty for an explicitly empty optional. Remember, optional.of will throw a null pointer exception if you pass a null value, so use it carefully when you are absolutely sure the value is not null. Let us put this into practice with a concrete example. Suppose we have a method that searches for a user by their identification number, and this user might not always exist in our database. Instead of returning null, which could lead to a null pointer exception, we can return an optional user. This clearly communicates to the calling code that the user may or may not be found. Once we have an optional object, how do we safely retrieve the value? We can use methods like isPresent to check if a value is present and then get to retrieve it. However, a much more robust approach is to use orElse, which provides a default value if the optional is empty. We also have isPresent for performing an action only if the value is present, and map or flatMap for transforming the value inside the optional if it exists. These methods allow us to write much more functional and readable code, handling both presence and absence elegantly. While optional is a powerful tool, it is crucial to use it correctly to reap its benefits. Let us discuss some common mistakes and best practices. A frequent anti-pattern is calling get directly on an optional without first checking isPresent. This defeats the entire purpose of optional and can still lead to no such element exception at runtime, which is just another form of a missing value error. Another common mistake is using optional in method parameters or fields. Optional is primarily designed as a return type for methods that might not have a result. Instead of optional parameters, consider method overloading or using a clearer domain-specific object. Remember, optional is not a replacement for null checks everywhere. It is a tool to make explicit the potential absence of a return value. Always prefer methods like orElse, orElse throw, ifPresent, map, and filter for safe and expressive handling of optional values. And there you have it, my wonderful students. We have covered the Java optional class from understanding the problem of null pointer exceptions to mastering its creation and safe handling methods. We learned about optional.of, optional.of nullable, optional.empty, and how to use isPresent, get, orElse, ifPresent, and map effectively. Remember, optional is a powerful feature for writing cleaner, more robust, and less error-prone Java code. It encourages you to think about absent values explicitly, leading to better design. The key is to practice these concepts. Try refactoring some of your existing code to use optional where appropriate. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to the channel for more advanced Java programming tutorials. Keep coding, keep learning, and I will see you in the next video. Thank you, and goodbye.